Hello, everybody. Welcome to the midterm 2 review video. So first, as with the last review video, let's go over and kind of list what we've covered since the last midterm. So last midterm went up to 1.8. So this one starts at 1.9, or at least the emphasis of the material starts at 1.9. So 1.9 was on graphing basics. And in that section, we covered things like the distance formula, and the midpoint formula. We also started looking at how to sketch graphs, sketching graphs, and we looked at intercepts and circles, if you remember all the way back. Okay, cool. 1.10, that was on lines. And the main takeaways from this one were the point slope form of a line and the slope intercept form. Along with, how to find the slope, intercepts of lines, etc., all kind of contained those ideas. Okay, then we switched gears and went to chapter 2. 2.1 was function basics. And the main thing that we dealt with in that section was domain and range. So finding domain and range of functions. 2.2 was on graphs of functions. And this section covered the vertical line test. .3 was using graphs of functions. And we did a whole bunch of things with this. So, we first, we used graphs to find domain and range. We also used graphs to find where a function is increasing and decreasing. We also, because those two things aren't enough, looked at minima and maxima. And then we also, in this section, looked at solving equations in inequalities graphically. So all right. Section 2.4 was on average rate of change. And as we talked about in that video, one of the main uses of average rate of change is to understand complex, or not complex, but complicated functions. All right. 2.5 was on linear functions and models. And this kind of built on our understanding that we've constructed about lines in general. And so in this section, we mostly focused on how to set up linear models, so setting up linear models. Linear models are very useful because you can usually approximate something with a linear model, and linear models are much more easy to deal with. All right, 2.6, which is the last section that we've covered before the midterm, is on transformations of functions. And the main types of transformations that we talked about were translation, reflection and scaling. But in that section, we also briefly discussed odd and even functions. All right. So this is the main sort of outline of the key points that we discussed since the last midterm. Obviously, this isn't everything we've talked about, but this is not a bad starting spot. So I'm going to do an example. I'm going to do one from the practice midterm. So let's say I want to find the domain and range of the following function. Let's do f of x equals, we'll make it piecewise. In the first case, we'll do x plus 2 absolute value minus 2 for x being less than or equal to -1. And in the second case, we'll just do x squared in the case that x is greater than 0. All right. So let's do the range first. So remember, for the range, we can do range of the first case unioned with the range of the second case. All right. So let's look at the first case first. In the first case, it is an absolute value, and we know absolute values are whatever's inside of it, they're always going to be greater than or equal to 0, which means that if we subtract 2 from both sides of that inequality, suddenly we have what we have up here, right? So we can replace a with x plus 2 minus 2 is greater than or equal to -2. So this right here is not quite the range of the first case. There is something to be said real quick. Since at -2, x plus 2 minus 2 is equal to -2, then it really does reach the equals case for here. So we can say range is, or sorry, oops, wrong direction. Range is everything equal to and above -2. So -2 to infinity. X equals. All right. Second case. The second case is x squared. And the thing about x squared is no matter what is squared, that's always going to be greater than 0, which means that x squared is greater than or equal to 0. And at x equals 0, we have x squared is 0 squared is 0. So now we have the range of the second case is going to be 0 and everything above 0. So that's 0 to infinity. So now the total range, or the range of f itself, is going to be -2 to infinity union 0 to infinity, which can be simplified to just -2 to infinity. If you draw out the number lines and sort of see where -2 to infinity and 0 to infinity lie, I think the simplification will be relatively clear. Okay, but that was just one half of the problem. Now we want to find domain. And again, the rule for domains is similar. So that's going to be domain of the first case unioned with the domain of the second case. All right, again, let's look at the first one first. So in the first case, we have this absolute value right up here. So we have an absolute value and we've got a -2 there. So we know about absolute values that absolute value A is domain everywhere. And just doing that -2, domain is still everywhere. Now we just have to be careful because this first case was only defined for x less than or equal to -1. So what we're going to do is so it's going to be domain everywhere, but we're only defining it for things less than or equal to -1. So what that looks like is an intersection. And so this first case, the domain is just -infinity, -1. Another way of looking at this is that, well, the first case is defined for everything less than or equal to -1, and the absolute value function part here in case 1 doesn't have any holes anywhere. So it just stays everything less than or equal to -1, in which case you'll get the same kind of answer. Okay, that was the first case. Let's look at the second. So the second case, it's x squared. And we know that that is defined everywhere. But so that has no holes whatsoever. But we're only defining it for x greater than or equal to 0. So if everything is equal and greater than 0, and no holes from x squared. So we say that the domain of this case is just going to be 0 to infinity. And so now the total domain, so the domain of f overall, is going to be -infinity to -1 from the first case, unioned with 0 to infinity from the second case. And that is the domain of the function. All right, excellent. I want to do one more example of finding maximum minima. Because I noticed some things on the homework that I wanted to address. So let's say we have a graph of something. And let's say maybe it looks like, let's say it looks like this. Let's do a line here, and then let's make it an open circle, and then we'll pick it out to about right here. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, this is it. 4, 4. And then let's also add maybe something in here that maybe looks like this. So let's do like filled in circle here, and then let's put another line in. So let's do all the way up to maybe about here, open circle. Okay, so we want to find the maxima and minima for this graph. So there's no curves to it. They're just two lines, but there is still maximum minima. However, it is not all the endpoints. So if we look at this first one right here that I've just circled in red, this is not a max or a min because the function is not defined on it. However, the second one that we see, this is a min because it's kind of the lowest point of that section of the graph. The one at the origin here is not max or a min because not defined. And the last point right up here, this is a max because it is the largest point of the graph sort of around it. So the answer to this would be the minima is at the point where this is. So that's going to be -2, 1. And the maxima is going to be at 1, 2, it's going to be at 4, 4. There we go. All right. So be careful when you're dealing with maximum and minima with the endpoints. I know that this is different if some of you have taken calculus, that you look at maximum and minima differently, but this is the way our book defines maximum and minima. So that's what I'm going to follow up with this course. All right. So that kind of went over some key points about what the midterm is going to cover. Keep studying, keep cracking at it, and let me know if you have any questions.